Hey guys, today's lecture, which is the final one of chapter 1, is going to be on absolute value inequalities. And I'm trying something different with my color scheme here. There's not a note handout for this lecture, so if you just want to take notes on your iPad or on a sheet of paper, whatever, that would be great. So when absolute value comes to mind, most of you probably think of what that symbol looks like, which is like the two looking parallel lines. And in order to get this in our graphing calculator, in case you ever had to do something like that, if you went to the catalog, which you can get to by pressing second 0, it's the first option. It says ABS, and then it has parentheses. So that's how we would get absolute value into our calculator. Now, when I ask my classes what they know about absolute value, here are the two most common responses. The first is that it's always positive, and the second really tells us why it's always positive. It is always positive because absolute value is the distance a number is from 0 on the number line. Their distance is always a positive value. Okay, if you're running around our track, if you can get past all the construction right now, it doesn't matter which way you're running on the track. Okay, if I'm running clockwise or counterclockwise, I'm going a positive direction. So absolute value is always going to be positive. To solve absolute value inequalities, there are really 5 different steps that we're going to be taking in order to find out what all of our solutions are. When we're going through this, the very first step we're always going to take is to isolate the absolute value. The majority of problems you'll deal with already have the absolute value all by itself, but if we see something else, we need to get that absolute value by itself right away. Our second and third step really go together. I'm going to split our absolute value inequality into 2 parts, and that just means that I'm going to write the expression twice, and I'm going to then set it equal to the number and its opposite. And the reason we're doing this is because I know that in order to get an answer of 8, whatever's inside the absolute value could either be 8 or it could be negative 8, because both of those values are 8 away from 0 on the number line. After we go ahead and do that, we're going to solve both of those 4 endpoints. And I do want to point out that we're setting it equal to. I'm kind of throwing away whatever that inequality symbol was. And then our final step, we're going to test the intervals for shading. So we need to figure out what values make a true statement inside our absolute value inequality. Example number 1. The absolute value of 2x plus 3 is less than or equal to 5. First thing we want to do is isolate the absolute value, but in this case, it's already all by itself. There's nothing else on that side of the inequality. So next thing I'm going to do is I'm going to take that 2x plus 3 and write it in 2 different parts, and I'm going to set it equal to 5 and set it equal to negative 5, because I know that if this is equal to 5, the absolute value of it's 5. If this is equal to negative 5, the absolute value would be 5. So I'm going to solve these independently. So I'm going to subtract 3, divide by 2, so I get x equals 1. Here I get 2x equals negative 8, so x is equal to negative 4. And then I'm going to go ahead and draw my number line. Okay, here's negative 4 and here's positive 1. If we want to, we definitely can use interval notation like we learned in the previous lesson. Or if you want to go back to using open circles, closed circles, I'm fine with that. It really doesn't matter either way on this. Okay, so we know that both of our inequalities, like our inequality symbol here of less than or equal to, tells me that these are going to be closed. So whether I'm using a bracket or if I'm using closed circles, we know that those are going to be present. Now, I don't know if I'm shading to the left, to the middle, or to the right, so I'm going to choose values from each of those intervals and substitute them in to see what works. Okay, so to the left, I'm going to try negative 5. So I have to do the absolute value of 2 times negative 5 plus 3 is less than or equal to 5. So I get the absolute value of negative 7 is less than or equal to 5. Is 7 less than or equal to 5? No. So I know I'm not shading to the left. To the right, to the middle, I'm going to try 0. 0 is always the easiest number to substitute in whenever possible. So I'm going to do 2 times 0 plus 3 is less than or equal to 5. So I get, is the absolute value of 3 less than or equal to 5? And that is a yes. So I know that I'm shading in the middle. To the right, I'm going to choose something like 2. So I have the absolute value of 2 times 2 plus 3 is less than or equal to 5. So I get the absolute value of 7 is less than or equal to 5, which is a no. So what that means is that I'm only shading things that are in the middle. I'm going to use brackets, as I said earlier, because of the equal to. And if you wanted to use closed circles, you could. One thing I want to point out, when we are working with absolute value, I would say 90% of the time it is either going to be in the middle or on the outsides. Now that's not always true. We should always test it for ourselves. And this part of testing, I know I wrote this all out right here. If you were explaining a problem to me, I would expect that you would write this all out. But on your homework, I think we're capable of doing this kind of thing in our head, so you don't need to write it out for me. I'm skipping a few examples that I did in class, so if you feel like after watching this video you need more help, you can go back and watch those examples just to get some additional assistance. So the second one we're going to do, the absolute value of x minus 16 is greater than 24. It's already isolated, so I can just go ahead and set x minus 16 equal to 24 and equal to negative 24. When I solve those, I get x is equal to 40 and x is equal to negative 8. Okay, so on my number line, there's negative 8, there's 40. I know that this is not closed. This is going to be open using parentheses because it just says greater than. So let's try some values. I'm going to try negative 9. The absolute value of negative 9 minus 16 is greater than 24. Is the absolute value of negative 25 greater than 24? And the answer is yes. So I know already that I'm going to be shading to the right. Now my prediction is that the middle is not going to work and the right will, but let's double check. If I put in 0, because that's between them. Okay, 0 minus 16 is greater than 24. Is the absolute value of negative 16 greater than 24? And the answer is no. Let's try 41. 41 minus 16, the absolute value of that is greater than 24. Is the absolute value of 25 greater than 24? And the answer is yes. So I'm going to shade to the right. Now the thing that I want to stress, and probably the biggest mistake I make, is people see this and say no. And we need to remember absolute value becomes positive. So the absolute value, the distance negative 25 is away from 0, is positive 25. So that's why it's true to the left and to the right. Okay, I want to go through two kind of strange circumstances that we will see. So if we look at number 3, our absolute value is already isolated, and it says greater than negative 13. Now, yeah, we might go through this entire thing and find all of our intervals and shade and do all that, but there is a quicker way. What makes this one different is that after the absolute value is isolated, this value is negative. I know absolute value, we said, is always going to be a positive number. So I need to think, when is a positive number greater than negative 13? And that is always going to be true. So our answer here is going to be all real numbers. Or we could write it in interval notation, negative infinity to positive infinity. Because whatever value we substitute in for x, the output is going to be greater than negative 13 is. If we look at number 4, this time we're saying a positive number is less than negative 2. When is a positive number going to be less than negative 2? Never. So our answer here is no solution, because there are no values that will ever work. Our last example for today, I'm pulling out a tough one that I would expect you to be able to do this on a quiz or test. And what makes this one more difficult is our absolute value is not isolated. And some things that we automatically want to do is combine these negative 4 plus 2. And the trick is we cannot combine them because they're not like terms. And that's because this 2 is connected to the absolute value. So it's like it said negative 4 plus 2x. You guys know you can't combine those, so think of that in the same way. Some of you might also be thinking, oh, well, the answer is going to be all real numbers because it's greater than negative 2. But the issue is the absolute value is not isolated yet. So before we determine our solution set, we need to get that absolute value by itself. So I'm going to start by adding 4 to both sides. So I get 2 times the absolute value of 3x minus 5 over 2 is greater than 2. My final step here, I'm going to divide both sides by 2. So I have the absolute value of 3x minus 5 over 2 is greater than 1. So at this point, I can set 3x minus 5 over 2 equal to 1 and set it equal to negative 1. Now, we can go through this a few ways, but I'm going to get rid of the division first. So I'm going to multiply both sides here by 2. So I get 3x minus 5 equals 2, because those cancel out. So 3x is equal to 7, so x is 7/3. On the other side, I'm going to do that same exact first step. So I get 3x minus 5 equals negative 2. So 3x is equal to positive 3, and x is equal to 1. So when I'm graphing this, okay, I have 1 and I have 7/3. I'm going to pick values, and I'm actually going to do the work in my head here. To the left, I could substitute 0 in. And I'm actually going to substitute it into this because I think that's easier to work with. So if I put 0 in, I get negative 5 halves is greater than 1. Is the absolute value of negative 5 halves greater than 1? Yes. So I know that I'm going to be shading to the left. If I pick a number in between, that would be like 2. So in here, I would get 6 minus 5 over 2, 1/2. Is the absolute value of 1/2 greater than 1? No, so I'm not shading in the middle. To the right, why don't we choose like 3? So I get 9 minus 5, which is 4. 4 divided by 2 is 2. 2 is greater than 1. So my solution set is going to be the values to the left of 1 and to the right of 7/3. I'm using parentheses because of this greater than sign that does not have the equals underneath it. If you're feeling good, go ahead and start on your homework. If you need a few more examples, watch the following video.